Hello and welcome back to another show from the field. I'm your host Casey. I'm based in, and this is and that was a fail. I accidentally forgot to mute myself from the actual Twitch show that I am actually presenting in, so I could hear myself. And it's really, really hard to talk when you can hear yourself talk. Anyway, so let's start it off from scratch. Hello and welcome back to another show of From the Field. I'm your host Casey. I'm SA based in Wellington, and we actually have a guest from over the ditch today. We have Yu Yang from Sydney, who has the site. Well, graciously is going to be sharing his knowledge around elastic load balances and all of that and diving into it. It sounds a little bit boring, but I can assure you it is not. It is a really interesting topic. I have, when we went through it, I think it was 2 days ago, I was actually quite impressed with what we're going to be covering. And just to freak everyone out, I think it is about 6 more weekends into Christmas. So that is how much time you have to, make sure you complete all of your projects and get everything across the line before everyone goes dark for a good probably 4 weeks or so. Do you have any big plans for the for Christmas break, Ian?
Well, probably go camping. Like one of my teammates asked me to go to, and then like some of the lake, like somewhere in New South Wales. I forgot the name, but yeah, let's find out.
That's a great start. Yeah, probably not the best idea to broadcast exactly where you're always going to be, unless you don't mind a bunch of nerds turning up and asking questions.
No, not at all.
Sweet. Do we want to actually jump into it then?
Yeah, sure. Yeah. Just wanted to quickly introduce myself a bit. My name is Yu Yang from I'm based in Sydney. I'm also an SA just like Casey does, and been with AWS for 4 years. Been through a couple different roles, and then it's my pleasure to talk to all of you today. And hopefully, I will be able to show you something when it comes to elastic load balancer, and then it will help your project. And hopefully, you can finish it before Christmas time. Let's see. Okay, sweet. Shall we jump to it for the site?
There you go. Yep.
Awesome. Okay. So as we've been discussed, like we're gonna talk about like different ELB types, and and also at the end of it, I will be able to show you a few like demos, like to show you how the ELB, some of the load balancer types can do, right? So this is the agenda. We will first have a 3,000 feet overview of like all the load balancer types, which is like in AWS. And we can I wanted to focus on like the application load balancer and network load balancer, since they are the most commonly used. And we wanted to tie it together at the end to see like what we can do using like ALB and NLB like separately, and also combine them together, what you can achieve, right?
I also find that network load balancer tends to be the one that confuses a lot of people.
Yeah. I hope like today's session, I'll be able to give you like an overview of like what's the difference, like which one to choose, like under what circumstances. But yeah, let's see how it goes. Okay. Awesome. Let's have a look at all the load balancer types first of all. So first of all, we have the application load balancer. If you have a bit of networking knowledge, you will know it is running on layer 7. So basically what it does is, what it means is speaking a language called HTTP or HTTPS. So we recently also added in the gRPC, so which is like going to be suitable for all the container workloads, which is going to be great helpful. It supports HTTP 2.2 like from end to end as well. So that's going to be great for your application. And as you can see, for the ALB itself, you can send the traffic to like IP addresses, EC2 instance, Lambda function, and also your container workloads. So in a nutshell, ALB is best suitable for your web application workloads, right? So apart from ALB, we also have the network load balancer, which probably confuse people. Basically, it speaks a different language compared to the ALB, using the TCP and the UDP. So which is on the layer 4 in the OSI layer structure. What it does is basically it has like extremely high throughput, ultra low latency. So that are some of the workloads which is going to be really suitable for the NLB. And it also depends on your workloads, which is on your like use cases, which I will just like dive deep into it to show you which one to choose. So as you can see here, The ELB can also send the traffic to IP addresses, EC2 instance, and also containers. It doesn't like support Lambda function, but it does support to send traffic to another application load balancer. So this is a brand new feature. Like it has been launched and people wanted to have it like for a long period of time. So I will be able to show you how that works, and also I will be able to explain why you wanted to use two load balancer, like combine them together into a system. So what are the benefits that can provide you? Okay. And then we have the old man, right? The old components, which is the classic load balancer. Like if you've been using AWS for long enough, like the classic load balancer was supposed to be just the one and only load balancer. That's why it supports like layer 4 and layer 7. So it can speak TCP, TLS, HTTP, and HTTPS. But at the same time, like the classic load balancer is not being like it lack a lot of features compared to application load balancer, and it doesn't have the same amount of like performance compared to the network load balancer. It can only send the traffic to the EC2 instance. Oh, and by the way, a lot of people got confused about like the classic load balancer and the EC2 classic. So to give you a nutshell, or to give you a brief idea, like the EC2 classic is like something exists even before the VPC ever becomes a thing. So at that time, like people just like launched the EC2 instance somewhere without like having the concept of the VPC, of the subnet, etc. We are going to retire EC2 Classic very, very soon. But like the Classic load balancer are gonna stay for a bit longer, and we're not gonna like at the moment we don't want to retire at the moment. But the Classic load balancer has been a old load balancing options, and all the new features, all the like internal team they are developing new features when it comes to application load balancer and network load balancer. So we would like to suggest you to try to consider using ELB or NLB instead of the CLB, unless like for specific use cases, right?
Yeah, and if anyone has any questions as well, feel free to ask. This is we kind of want this to be as two-way as possible. If you don't have any questions, that's all good. But yeah, we just don't want to be like throwing knowledge in one direction. I'm not mentioning the band there, but yeah. Anyway, keep going. I just want to make sure that people ask some questions.
Yeah, absolutely. If you have any questions or whatsoever, like I'm happy to answer. Like and yeah, let's find out like what's your use cases and then which one going to be best suitable for you. Right, and lastly we have the kids, right? The brand new one, the GWLB, what we call the gateway load balancer. So it's a special one. It works on both layer 3 and 4, which is it speaks IP protocol, and also it understands a bit of like TCP as well. So most of the time, people use the gateway load balancer as an entry point for when they wanted to monitor the traffic, like sending out from their VPC to the general internet. So probably what they're gonna do is like they put some of the firewall appliances behind the gateway load balancer, and then the gateway load balancer will be the one who handles that, and then to make sure like each of the firewall can receive the same amount of traffic, so that we're not gonna like overwhelm just one single or like a few of them. So basically, those are the load balancing options that we provide at the moment. So just like Casey mentioned, like people can get confused. So hopefully, from now we will just like try to dive into the application load balancer and network load balancer, since like they are most commonly used by most of our customers, and then we'll be able to break it down and then show you what they can do, right?
Yep. And for some of these, we also got a demo towards the end, right? A demo and example architectures.
Yeah, definitely. I prepared a demo and also an architecture which can show you what it can do. So yeah, stay tuned. All right. We wanted to talk about like application load balancer real quick. Like most of the information has been just been covered already. So it is like talking layer 7, like using HTTP or HTTPS. It supports a bunch of features such as redirect, weighted routing, fixed response. So each of them have a different kind of use cases. I will talk about like the redirect like in the following slides, but like I do wanted to touch based on the weighted routing. So what an ELB can do is it can send like partial of its traffic to one of the what we call the target group. You can think of it as one subset of the resources and the rest of the traffic to another one. What are the benefits, right? Why people wanted to do that? If you are ever like been like trying to develop your system with the CI/CD pipeline in place, you will understand why. So for example, if you wanted to do a blue-green deployment, so that means like there will be two different versions active at the same time. So how do you manage to send the traffic? That's where the weighted routing come into the picture, and that's where it can be super helpful for your use cases. So you can decide it, how much traffic you can send it to the new version, and then in that way, a blue-green deployment or a canary deployment can be done, right? Another really commonly used feature is the authentication one, which I will also show you in the demo. So what it does is it basically using another AWS service called Cognito. So the Cognito can be then integrated with social identity providers such as Amazon, Facebook, or Google, or even Apple. And then like it can finish all the authentications and then get it back to your application so that you will know, okay, this user is genuine, like he or she has the access to whatever resources like for their account. So I will show you in the following demo. Stay tuned. I'm gonna use Amazon as the social IDP, but yeah. Another thing which is like quite important is the web application firewall, the WAF integration. Funny that like Casey, you mentioned about Christmas. I still remember like my last Christmas was not that fun because of the Log4j, right? I'm sure like
yes.
most of you like still remember like everyone's like quite happy we are ready for the Christmas, and then all of a sudden Log4j pops up, and then everyone has to put their hand on the keyboard and trying to fix it in a way, right? So I still remember that time, and then that's where the WAF actually helps a lot of our customer. So as far as I remember, I think like after like 2 or 3 days, our internal team came up with a rule which it is able to help you to mitigate the issue brought by the Log4j issue, and then that rule can be enabled into the WAF, the web application firewall, to protect your application. That saves a lot of time for a lot of our customers. But yeah, I still remember that there is like millions of customers, like a huge amount of customers just reaching out to us and say, okay, here's a problem, what you can help us. And WAF was the answer. And ELB has a deep integration with the WAF, so it's just natively supported. It's going to be much easier for you if something went wrong. And there will be other stuff such as like stickiness, or like the ELB also support like the outposts and local zones, which is like our AWS hybrid environment. But yeah, like if you have any questions, like feel free to shoot it into the chat, and Casey will let me know, and I'm happy to answer. Okay. I want to talk about like the most commonly used cases when it comes to ELB, which is website hosting. It sounds simple, but ELB can actually help you a lot. So when it comes to that, first of all, we actually
do have a question that comes on, and this is a very good question. This is something that I come across a lot, and it also is something that causes a lot of issues with people that aren't familiar with the AWS infrastructure and how it does the health checks. So is there a way to configure a health check from an ELB to a REST endpoint that requires an authentication header password protected application?
Okay, yeah, that's a great one. Generally speaking, like what we suggest you is actually sending the traffic to a like separate health check page, because like the health check itself is relatively straightforward. It will send a HTTP 1.1 GET request to whatever like the pathway you configure, and then what it's like expecting is basically just a status code. So with ELB, you can configure the status code between 200 all the way to 499, as far as I remember. So as long as it send a GET request and it get a response with the HTTP status code as 200 all the way to 499 based on your configuration, it will mark it as healthy. So that's how it works. As far as I know, like you are not able to configure the GET request to send a special header or whatsoever. But I think like we can definitely consider something else, like probably including a Lambda function, etc., to mark the if the Lambda function send the request and then get the response, and then it can be used to mark the EC2 instance or the target as healthy or unhealthy. So that's definitely can be done.
The other one to keep in mind is that the health check URL quite often will have HTTP to HTTPS redirects. You need to make sure that that redirect isn't enabled for that particular route.
Yep.
Otherwise, you'll get a challenge or a redirect response, and that will make the health check fail.
Yep.
And a health check needs to check that the application is healthy, not that a redirect response is done. And that's where I find a lot of people fail as well.
Yeah.
Follow-up question is that can we leverage a Lambda function as a health check?
Oh, absolutely. Yeah, I've seen like a lot of people using that. So you can just basically having an event engine to trigger a Lambda function with a schedule, and then like just at the end of it calling an API which is like mark the instance as healthy or unhealthy, and then you can have other services such as auto-send group to automatically rotate the instance if that's needed. Yeah, absolutely.
Yeah, you can hook into lifecycle events and trigger.
Yeah.
Correct.
Like Casey, what you mentioned over there is like quite interesting. That like when people need to set up like the HTTP to HTTP redirect on the EC2 instance, that's exactly what happened before. Like when you're using the CLB, but as a matter of fact, when you're using the ELB, you don't have to worry about that anymore. So basically what ELB can do is it understand what protocol which like the customer sending the traffic using. So if it's HTTP, it will automatically redirect to HTTPS. So you don't have to do anything on your application level to handle it. ELB does it for you. I will show you in the demo. And the other really important feature when it comes to like TLS is like the TLS termination, right? So the TLS termination, like I've read some of the research over there. Like as we all know, the TLS is like the negotiation is based on like mathematics. So it consumes a lot of power when it comes to your virtual machine. So what ELB can do is ELB will just finish the HTTPS, finish the TLS like termination by itself, and then it will just use its like own capacity to finish it, and then you don't have to worry about it. Your application does not have to worry about it anymore. So then that not only saves you a lot of like computation power, but also it saves you money as well. Because like if you wanted to getting a certificate, SSL certificate from somewhere, you have to pay for it, right? And every single year you probably have to renew it, right? Which is like a lot of people told me it's a pain. But what ELB can do is ELB working with another service called the Amazon Certificate Manager, and it can provide you a free certificate, a free public certificate to be used on the application load balancer or the network load balancer or even CloudFront, and it automatically renew itself every year. So you don't have to worry about like getting a new certificate and do all that kind of stuff.
The one caveat is that you can't export the private key, so you can't use it on other platforms. So that's one caveat.
Yes, that's exactly right. But like it is like you can definitely use it on the ELB service, like the AWS services such as ELB, NLB, CloudFront, and API Gateway. So it's a free certificate which like you don't have to manage, right? Another use case is like which is commonly seen is like the virtual website hosting. So I've seen some of the customer, they hosting their website for their clients, and they hosting many websites on a single endpoint, where like this is where ELB can help you. So ELB itself support SNI, which is what we call the server name identification. So what it means is it can have multiple TLS certificate installed on the single load balancer, so that you will be able to use a single load balancer to handle a lot of traffic from different websites. Okay, so I will also show you that. So for my ELB, I have 2 certificates assigned to it, and then ELB will understand which certificate to be shown to the client, and also which target, which EC2 instance, which website to be shown to the client as well. I've talked about user authentication and web integration, and I will dive deep into advanced routing when it comes to the demo session. I will show you, okay, so the customers like using a certain type of like website or like the host or the DNS name, ELB understands it, and if you are using a certain type of like path, it understands it, and also it can do other stuff such as like authentication if you wanted to do using a certain type of like domain name, etc. Okay. So that's a quick overview when it comes to ELB, and let's jump into network load balancer. In comparison, right, to ultra low latency, and it has a extremely high capacity by default. It can handle like millions of requests per second, like the moment you launch it. Right, network load balancer can do that without any hesitation. It also can provide you a zonal isolation, which means if you wanted to keep the traffic within the same availability zone, you can do that with network load balancer. You might want to ask why. So that comes back to the first requirement, which is ultra low latency. So if you keep the traffic within the same availability zone, you can have the ultra low latency between the server and the backend. It also supports like long-lived TCP connection and also UDP traffic. So another quite commonly seen use cases is like customer put a network load balancer in front of their DNS server. They have a bunch of DNS server behind the network load balancer, and then the network load balancer understands both the TCP and the UDP, so it can just pass the traffic through to the DNS server, etc. Private link, which is another really common use feature, and the ELB is actually the foundation for the private link. I'm not going to dive too deep into private link because it deserves its separate topic. But essentially, what a private link can do is it allows you to expose 2 of the endpoints inside of like your entire VPC to your customer, and then like your customer will able to just access those 2 endpoints for your services, and you don't want to, and also for you don't have any security risk. Lastly, which is also very, very importantly, ELB supports static IP. And also you can use your elastic IP for the ELB. This is actually one of the use cases where customer really wanted to have when it comes to ELB because of like the firewall. I will dive deep into that in the following slide, and also in the demo. I will explain why people wanted to have a static IP, why it is so important. Okay. A commonly seen use case like for ELB will be the gaming industry, right? So it's commonly used for the control channel, the chat session, and also for the game connectivity itself. The reason why people wanted to use ELB is it has the ultra low latency, which is exactly what you want for the game, and it provides the long-lived TCP and UDP connection. Essentially, ELB is like working on the layer 4, right? So it doesn't like perform a lot of analytics when it comes to the request. So that's why it can provide ultra low latency, which is like really, really crucial for certain use cases, right? For example, like gaming, I used to play a lot of League of Legends, and then like I couldn't, I like sometimes that when there's like a network like just like a tweak, and then I just like what's going on? So you don't want to have that. And ELB can help you to make sure that the latency can be absolutely minimum. And The other thing which like ELB come into the picture is if the customer traffic is not using HTTP, right? So for example, if you having the DNS server, if you having the email server, which is the SMTP, or I've seen customer wanted to use ELB in front of their Windows server so that people can use that as the single point of entry, the entry point for their RDP session. So as long as like the traffic is not HTTP based, ELB can be a good choice, right? So it's more like a catch-all option for all the other traffic types. Okay. So how about we combine them together, right? So ELB and ELB, they have like all different kind of features. How about we combine them together? So this is one of the commonly seen use case. And then like by the years I've been with AWS, this is the feature which I cry to the service team to ask for them, to beg them to give it to us, is we can enable like the static IP on the ELB. So why is that? As you can see here, like we have a lot of customers, like they have their corporate data center, and when the server trying to reach out to the internet, it has to go through the firewall on the corporate data center. But a lot of the firewalls are based on IPs, right? So if the IP changes, like you have to inform the customer, inform them like they have to update the corporate data center rules, the firewall rules. However, ELB, because it is able to scale itself and also we monitor like all the hardware. So the IP of ELB can change. And the IP of like the changing ELB IP is like we manage that, right? So it can happen at any time. That is why people sometimes like just like put ELB in front of the ELB so that the ELB IP doesn't change, and then the ELB IP can be whitelisted in the firewall rule. But that's gonna be another problem coming into the picture, because even you put the ELB behind the ELB IP can still change, right? So at that time, that's like a solution proposed by one of the internal team member was that's a Lambda function being called every minute or so, and then it run a DNS check on the ELB DNS name, and then see whether the IP changes. If it change, it update the ELB to let them know, okay, it has been changed. If it hasn't, it will just keep running itself. So that means like you have to have like a template-based like Lambda function running all the time. You have to keep record of like all the ELB IPs. And yeah, but because of these kind of use cases, people has to use it until last year. Last year they announced it. You can just like put the ELB as one of the target of the ELB now. So which means ELB and ELB, they can talk to each other directly. And we will handle if something goes wrong or if the IP changes on the ELB. It changed the game completely. So nobody has to like set up a Lambda function to running over time and all that kind of stuff. Like AWS, we just handle it. And then the ELB IP can be static, and then customer, they won't have any problem to access it no matter what. So yeah, this is one of a great launch for last year, which my personal favorite, because it solves a lot of problem, and I'm happy to show you in the following demo. Okay.
I also remember that workaround. It was not fun in the least.
No,
it was a lot of admin, and it was kind of like, why are we doing this again?
Yes.
And there's another question that came in. Is there a workaround to preserve the IP for ELB, since NLBs are pretty expensive?
For preserving the IP, so if ELB is like a bit expensive option, the other one which you can consider will be the transfer accelerator. So that one can be used. It's also providing a static IP, and you can put the ELB as the backend, the global accelerator. Sorry, the global accelerator can be put in front of the ELB as a static IP, and then just like using that. But like at the other time, like so a lot of the new version of firewall, like they have become like more and more advanced, and more cloud native firewalls are coming into the picture now. So they are trying to whitelisting the DNS name instead of the IP addresses. So that's another sign which we've witnessed in the field. People notice that change, and then people will trying to catch up with how the cloud works. So let's find out. And if you have any questions, like we can just dive deep into what are the options for you when it comes to if like NLB is a bit too expensive for your use cases. Happy to have a chat.
Yeah, well, the one thing out there is that the physical firewalls are in virtual appliances. There is a massive disparity in terms of the features they have. So yeah, there's always going to be workarounds and ways to make things work together, and using the limitations at hand. And yeah, Global Accelerator is one of those.
Yes. But at the same time, like these entire like combination between ELB and NLB is like really welcome by the field, since like it solves a lot of problems. Like having that workaround was not fun. I've been into multiple that kind of deployment before, not fun at all.
Yeah. Also, pretty fragile, because that means you could have that backend being down for at least a minute, or at most a minute, I should say.
Yes, exactly. So that's also gonna happen. And then if your traffic is like super high, like a minute worth of downtime is not acceptable as well. So yeah, absolutely. So I wanted to just like bring them together and talk about like which load balancer to choose. So basically, you can make the decision based on like just asking yourself a few questions, right? So first of all, do your client connect to you via non-HTTP protocol? If your answer is yes, then NLB will be the choice. If the answer is no, they only use HTTP, ELB gonna be 100 times. You ask me 100 times, I will answer you 100 times ELB, because it provides a lot of additional features. I will show you in the demo. Second question is, do you need to minimize the latency? If the answer is yes, NLB. Even when the traffic, even when your customer traffic is using HTTP, NLB can provide you like the ultra low latency. And if that's the most important thing for you, choose NLB instead of ELB. Does your traffic pattern highly unpredictable? Which means like if your traffic, it can be probably 10 users at 1 minute, and then becomes 1,000 users at next minute, and then goes back to 100 users like in the next one. It would be, if that's the case, NLB going to be a better option, since ALB can handle like the spike traffic better compared to the ALB, because NLB has a large capacity by itself, by nature. Whereas for ALB, it automatically monitors everything, and then it will scale itself based on the load. However, like what I mentioned here is like if your traffic is unpredictable, but if your traffic is predictable and is using HTTP, we will suggest you to use ALB, because it provides more features. And as AWS, we can help to do something called the pre-warn. So if you talk to the wonderful AWS support team, they will be able to make sure your ALB is at the right capacity before your event. The event can be your flash sale, or your Black Friday events, or like Cyber Monday, etc. So if you expect there will be a traffic spike during that period of time, you can always reach out to us, and we will make sure the resources is at the right capacity for the ALB. And we have already answered that question. Do you need static IP? If you do, NLB, or combine NLB and ALB. So the reason why people wanted to combine them together is they wanted to have static IP, which is provided by the NLB, and they wanted to use the advanced HTTP features provided by the ALB, right? So you just combine them together, and then becomes a joint force, becomes more powerful. And then, do you need advanced routing based on headers, query strings, etc.? If you do, ELB will be the best choice since like it provides such functionality. And if you wanted to, do you require advanced security features such as AWS WAF or security group on the load balancer, then ELB is going to be the choice. I do wanted to touch quickly on the security group one, since like ELB, you can apply a security group on ELB, but currently you cannot apply a security group on NELB at the moment. I know that's a feature request, and it has been a feature request like for a lot of customers. I hope like this is a feature which we will be able to announce soon to enable security group on NELB as well. But yeah, those are some of the questions that you can ask yourself when you're facing the dilemma, which type of load balancer you should choose. And if everything's okay, I will show you a quick demo and to show you what ELB can do when it comes to what are the advanced features, etc.
While we wait for any questions that come through, why don't you jump straight into the demo? And I'm also going to say that it still really annoys me that those texts don't line up.
Yep.
But that's just because that's how I roll.
Yeah. So, well, I'm sure like it will like all those problems will solve at the end. So we're just like hoping for the best, you know. I hope like everyone can see it. Do you need me to zoom in a bit more, or is that okay?
Yeah, that should be fine. If anyone can't see it or wants to use zoom in more, they should just be able to send us a message.
Okay, sure, awesome. So I wanted to run the first demo on the ELB. So I wanted to show you a few things like when it comes to the feature of the ELB itself, right? So first of all, we have the customer, and then they are using the DNS name to access your load balancer. As you can see here, I do have 3 different domain names pointing to the same load balancer, right? And as you aware of, like if you're trying to using the HTTP protocol to access some of the services, it will definitely, your browser will screaming and say, this is insecure, you shouldn't do that. And you have to make sure like the ELB has multiple different TLS certificate assigned to it. And this is what happened here, exactly what happened here. So I'm using a free, like 2 of the free certificate provided by the AWS Certificate Manager, and they are all assigned on the ELB itself, right? And then when your customer trying to reach out to the load balancer via the DNS name, first of all, like as you all know, like people are lazy, right? Nobody type HTTPS when they're trying to access Amazon.com. People just type Amazon.com, and by default, it will be HTTP traffic. So ELB, what it can do is it will just automatically handle it and then redirect to tell your server that, okay, we need to redirect it to HTTPS. So ELB just does it by itself. And when you see like the different kind of customers like trying to reach out to the website with a different domain name, ELB also understands it, and then it will send it to different web servers. So it will help you a lot if you wanted to run a virtual website hosting type of workloads, because you can add multiple different domain name on it, and you can add multiple different like targets on it. Okay, let me just do a quick show. So for example, first of all, I'll just quickly show you the environment, how that looks like. So we have yuyangwu.ninja, which is like a domain that I own. And also the other ones like yuyangwu.com. So if you have a look here, the twitch.yuyangwu.ninja pointing to the ELB demo, which is the same as twitch.yuyangwu.com. It also points to the same load balancer. And in the load balancer itself, I have 2 listeners. The first listener is on HTTP, listening on port 80. And the second listener is listening on port 443, which is like using HTTPS. In the first listener, I have a rule to automatically redirect the traffic, which is like whatever traffic landed on itself, it will automatically redirect to the HTTPS listener. right? So that helps us to run the TCP, the HTTP redirect. And on the second listener, there are a couple different rules here, and I will jump into it, but I want you to focusing on these two. So first of all, if the domain people using is twitch.yuanwu.ninja, it will send it to one of the target group, which is called demo ELB target group. And on the other hand, if customer using twitch.yuanwu.com, it would then send it to another target group, which will show them a different web page. And at the same time, I wanted to show you that you can see there are multiple SSL certificates assigned to it. So one of the certificate is it's the wildcard for yuyangwu.ninja, and the other one is the wildcard for yuyangwu.com, right? So if we try to access it, just like your normal customer, it will be just Twitch yuyangwu.ninja. Be aware, I didn't put any HTTP or HTTPS at the front, but if I hit enter, you see it automatically does that to show you as HTTPS, right? So that will be the same if I do twitch.yuyangwu.com, right? It does the same thing. It just automatically do the redirect, but as you can see, the website is actually different. So this website is for twitch.yuyangwu.com, and this is for twitch.yuyangwu.ninja. So ELB just handles it all. ELB just understand what domain name you are using, what protocol the customer is using, and it will just act on its behalf. So without you going into the server and then trying to import the certificate to the Apache or Nginx or whatsoever, and then trying to configure the redirect role, right? So it saves you a lot of time on that. Another great feature for the ELB is the authentication, which is a lot of people using it. So as you can see here, one of the website of yours needs the user to be authenticated, which is yuyangwu.ninja. And then ELB will see if customer using trying to access the website using auth.yuyangwu.ninja, it will automatically talk to Cognito, and then Cognito will have the social identity provider enabled. And once it has been successfully logged in, ELB can do the rest of the stuff. So what I've been configured here is if customer using auth.yuyangwu.ninja, it will automatically go to Amazon Cognito for authentication. And then once everything has been done, it will return an HTTP 200 request and then say you has been authenticated. So that's what I configure here. If we look at the listener role again, so if we are using auth.yuyangwu.ninja, it will go to Cognito and then return a HTTP 200 request. Okay, let's have a look. So I will do the same thing without typing anything with HTTPS or whatsoever. I will just do auth.yuyangwu.ninja. And then I'm using a private browsing, so it doesn't have any cache. So if I hit enter, it automatically redirects me to the login page. So if you have your own login system, you can use it, but I'm using a social networking login, which is Amazon.com. If I click on it, it automatically forward me to the Amazon sign-in. I can just use the user account and also the password to sign myself in. Once I'm signed in, ELB will send the traffic back to your application. In my case, it just simply send a "you are authenticated" word to the page. But for you, it can be the, for example, your shopping carts, your other services, etc. So that's how easy to set up the authentication, just by that. So you can use all the social networking, such as as we mentioned, Amazon.com, Facebook, Google to do that. It saves you a lot of time to having yourself to manage the logic within the application itself. ELB does it for you. The other features which are quite commonly they are commonly and quite easy to understand. For example, if a lot of like bots on the internet are trying to get your website into the admin page, so you can just return a fixed response by 403. So which is just tell them, okay, this is forbidden, and if nothing can be found, ELB can just send a 403 and ask you, are you lost? Right? So ELB just simply can block all those like unnecessary traffic to reach out to the application. But these type of stuff can also be handled really well by the network load balancer. By the web application firewall. So like the traffic will not ever reach out to the application firewall at all. The WAF will just simply block it. But just give you a quick idea. So if I do Twitch and then admin, so it will just like return a forbidden. And if we look at the developer tool, so it will show you as a 403 error being returned by the load balancer, as you can see here. So this is a quick demo when it comes to ELB and also all the features provided by the ELB listener. Any question? Anything you want me to dive slightly deeper into it? Okay, right.
Left myself muted and trying to talk. I do
Yes.
that far too often. I am absolutely useless at this. Yeah, if any questions come through, just keep going. If any questions come through, I'll stop you. I also see that we got a hello from Atlanta, which is a fair bit away. I believe it's like 6, it must be 6 p.m. or something like that now. And it's yesterday, 6 p.m., not today, 6 p.m.
It's good to have some regular viewers over there. But hello, I'm a new face. My name is Yuyan. Say hi to from Sydney.
Yeah, I was going to say, he has to know where you are first.
Yeah.
Or she.
So if like the ELB one's like quite straightforward, and then we can quickly have a look at the how we can combine the ELB and the NLB. So we briefly touch it. As you can see here, so my system is set up like in a VPC and it's in a customer VPC. So the client server has a really restricted security group rule. So basically my security group rule, I will be able to show you later. It only allows outbound traffic to the NLB like IP addresses, as you can see. So that's commonly seen when it comes to some of the firewall rules, right? So it just violates a certain set of IP, and that's about it. Because of that, we have to use an NLB, and this NLB will be a public one as a public entry point, and it has the static IP, which is I put it there. And as we mentioned earlier, you can use elastic IP for that as well. And behind the NLB, it has a private application load balancer registered as the NLB's target. So the ALB is residing in the NLB target group. And then at the back of the ALB, that's a ALB target group, which has an application server. So by using this architecture, right, customer, even they have a really restricted firewall rule, they will still be able to access the service without any problem. And also from AWS perspective, we handle the load balancing, and also we handle the traffic, just in even if the ALB needs to scale itself. Okay, let's show you real quick. So we have the NLB ALB integration network load balancer here. So AC has in 2 listeners. One's on TCP port 80 and the other one's on TCP port 443. Both of them are forwarding to different target group. So first of all, the first NLB target group is sending traffic to the internal ALB on port 80. And then the other target group is sending to the internal, which is the same load balancer on port 443. Funny enough, it shows as unhealthy, but yeah, we can dive deep into it. So, and then we have the private ELB running at the moment. So the private ELB is having is forwarding the traffic to the oh, sorry, I think I put the wrong one. So internal, yeah, that should be the one. So the internal ELB, that's the one which is like registered behind the network load balancer. The port 80 listener is also, again, doing the redirection, and the HTTPS listener is sending the traffic to the ELB, to a bunch of application server. And we have a example customer instance. This customer instance is like residing a different VPC, and it has a very restricted security group rule, which only allows traffic, outbound traffic, to certain type of IP on certain type of port. So let's have a look. What if we try to access the website, and also if we try to access the network load balancer, what's going to happen, right? So as we mentioned earlier, so the website we're using to point into the NLB is called nlb.yuyangwu.com. Let's do it. Ooh. So sorry about that. I have already SSH into the instance, right? So let's run a quick one. If I try to curl HTTPS and Amazon.com, let's see what's going to happen. So it successfully resolved the IP address of Amazon.com, but when it trying to send the traffic out, nothing happens. So that means the traffic has been dropped by the security group rule, and then that's because and at the end of it, it will just generate a TCP timeout error. But if we do a thing, which is like, let's try to resolve the DNS name of the network load balancer. So it resolved to those two IPs. And what if I try to access the network load balancer? As you can see, it's successfully connected to one of the load balancer IP address, which is showing here on port 80. But it shows you a HTTP 301. That means we need to do a redirection. So to redirect to what? Which is https.nlb.yuyangwu.com on port 443. So let's do it again. And as you can imagine, so this redirection is actually provided by the ELB, because ELB does not understand what is HTTP. So that's exactly the reason why people wanted to combine NLB and ALB together to provide you combined use cases. I don't know why my light is coming off, but anyway. And as you can see here, so if I try to connect it via the port 443 on the same domain name, right? So it finished all the TCP, the TLS handshake, and then it gives us the result. It said, hello, this is a page for ALB demo, and this is a page used for ALB and NLB integration. So as you can see here, even we have a really restricted rule on the customer instance on the outbounding traffic, it's still able to access the NLB because it has a static IP. And also you can still benefit from using the ALB, as ALB like does the HTTP to HTTPS redirection. And you can enable other features which we covered earlier. So that's the magic of like having such configuration, and then you don't have to worry about what if something got changed. So this is a really game changer for a lot of customers. But yeah, I hope like you will find it useful as well. So that brings end to my content. So is there any questions or like in the chat? Sorry, like I looks like a creepy movie for some reason. I mean, in the office, like, oh, there we go.
Yeah, you weren't moving enough, so therefore it decided that you weren't alive and that turned lights. We have been asked, are there any blogs on this topic? I imagine so.
Oh, yeah, absolutely. Actually, as a matter of fact, I do want to highly recommend everyone to go to this website to explore a bit. So this is a full website to talk about all the different kind of features, and then it provides you a bit of a demo. All the features are provided by the ELB. Due to the time limit, I can only cover a bit of it. But if you, for example, if you wanted to learn more about gRPC for your container workloads on ELB, just use it. So this is a great page for you to explore all the features when it comes to ELB and NLB. For example, how to use ELB to trigger a Lambda function. So I will drop it into the chat.
I've already done it. So
thank you. Yeah. So yeah, this is a great website. I would highly recommend everyone to have a look. It has a bunch of demo and it shows you what can be done basically.
Nice. Thank you for the question. If there's any other questions, then please. Why can't an ELB have a static IP? You should.
That's a great question. Yeah, that's a great question. So ELB is based on different type of node. So we basically start from a smaller type of node, and then we can grow that node size to massive. But whenever we need to do anything like that, it replaces the node, and then by the time it replaces the node, it comes up with a new IP. So it is like more like a trade-off, which is like just as our day-to-day life. So if you wanted to have the ultra high, ultra elasticity, or you wanted to have like a static one, which you bind it to that one, and then what if something goes wrong with that piece of hardware, right? So that's why ELB like does not have static IP, because it does do that balancing, and also it scale itself, right? So we help you to monitor everything and then to do everything on that.
And then the follow-up question, I actually think this is a great recap. So yeah, I'm really enjoying this. So why is that not a problem for the NLB?
Yeah, so NLB is like having a different architecture. It's what we call the hyperplane. So the hyperplane is a massive network over there, which supports like other services such as transit gateway, NAT gateway, and also of course NLB and a private link. So because of the nature of hyperplane, it just has the capacity by itself. But on the other hand, hyperplane does not understand HTTP, right? So it does not provide you all the advanced functions such as redirection, the authentication. So that's the difference between these two. And that's basically how you make the judgment. Okay, which one to use, which one best suitable for your use cases.
Awesome. I think that's was really well put, and as I'd expect, as you have dived very deep into these topics over the last couple of years, haven't you?
Yeah. So just a bit of background. I used to be part of the AWS Premier Support team. So if you ever open a ticket when it comes to CoreWatch, load balancer, auto-scaling group, you might have talked to me. So hello again. But yeah, I recently changed to the SA team because I wanted to see other stuff. But at the same time, I still have a lot of reach out from the customer asking questions related to auto-scaling group. Elastic load balancer. So yeah, like people having trouble to access it because of the security group, because of the network configuration, or which one to choose. So that's why I found that probably we can have this session and then trying to bring more clarity into that topic.
Awesome. If there's no other questions going to come through, then I thank everyone for. Oh, no, there's one more. How can we reach out to you for any questions? So this is a great question. So I can start. So we do have a LinkedIn group called AWS New Zealand Technical Community, because this is a New Zealand-based show. So feel free to add yourself to that and throw any questions you want in there. Or you can track us down through me, either LinkedIn or Yu Yang through LinkedIn. You don't have your last name public, so it's going to probably be a bit harder.
It's Wu. So everyone saw it in the domain name. So my name's Wu Yu Yang. So Yu Yang Wu. Yeah.
Yep. And the other one is you can also fill out the contact us. There we go. So I think my internet's playing up, which is a bit of a pain. And also there is the contact us form that you can fill out if you do want to. That will eventually get you through to the account team that manages you, or you'll have a what's known as a DGR reach out to you, and they can actually connect you through to either support or someone that is an expert on that particular area. Or you can, as I said, reach out to that group, request to join. Then you'll be able to find me because I'm one of the admins of that group, and just ask you a question there, and then I'll reach out to you, and actually we can have that private conversation in the back end.
Yeah, my team also help a lot of customers based in New Zealand as well. So yeah, let's have a look and let's have a chat if you have any questions.
And support is always amazing as well. So if you do have support, always reach out to them. They are a wealth of knowledge, and I do quite often will hit them up in the back end along with the service teams because they have probably dealt with a lot of the stuff that we're asking questions about. So again, thank you so much, Yang, for sharing your knowledge and taking the time out of your day to actually share this absolutely amazing presentation, and also setting up all of those demos. That was awesome, and I think I speak for everyone. There was a lot of questions that came through. If you did catch last week's episode where we had Consigna talking about the automated deployment of VPCs and Transit Gateway, then they have just made that code base public. So you can go to this GitHub link. It was private over the weekend, but I've just got them to open it up now. So you can go there and dive into that code that was presented last week on From the Field. So from there, thank you, everyone, and thank you, Yang.
It's my pleasure to be here. Hopefully I can see you guys soon.
Yep. And as we race up to Christmas, I hope everyone has a fun festive period. We will be airing weekly into the 15th of December. So till then, I will see you next week, and look after yourself, and hope everyone has a great week ahead of them.
Have a good one. See you guys.
See you.